Well, hi, and here's the next thing I'm going to be working on. It's a really beautiful, I believe it's a General Electric radio with a very common chassis in it. Big beautiful speaker down there and a steerable antenna. Inside, push buttons at the bottom there. You can't quite see maybe in this image. But that's coming out, chassis is coming out and heading for my shop. Okay, so pulling the chassis out of here is not the easiest of all radios because it's connected to quite a few things. So there's an antenna plug over here which has to come out. And these totally destroyed antenna wires will have to be changed eventually. And then I do need the speaker because it's got a field coil on it and I really want to use the correct speaker. So I have to get the speaker out of here. Lastly, a little hard to see, we can't see it in the dark, but the push buttons on the front of the radio here, these are not attached to the chassis. They're actually separately installed below the chassis. You know, this is a great deal of flexibility with this chassis from a radio manufacturing point of view because the buttons can go below, they can go above. I think that's one of the reasons why this chassis and a few others very similar to it were very popular, because of the flexibility of this radio working in big floor standing models like this and also in tabletop models. So I'm just going to work away and remove all this stuff and get it into my shop. Okay, so I have removed everything I need from the radio cabinet to work on this radio, and it's quite a bit of stuff, of course. First I need the chassis here. Okay, here we go with that. You notice the number dial has not come in. That's stayed mounted on the cabinet. In the case of this radio, though, it has a very handy chart on the back here that you can use to do the calibration with, so you don't need the front panel to do this radio. But you do need some more stuff. Let's see, you need the push buttons. You need these to be plugged in. They're unplugged there. They need to be plugged in when you're doing this radio. If I remember right, the audio signal is fed up through the push buttons because one of these push buttons will turn on a phono input. So the audio comes up through here. Without it, no audio is going to come out of this radio. So you need that. Okay. And for this radio, you also need the speaker. So I have the speaker here. As you can see, the cone is exposed completely. It looks to be in very good shape. There's a little bit of mold down here, but otherwise it seems to be in very good shape. A little dusty on the back. So this big guy's got to be in here. Of course, you got to be careful with the speaker for fear of damaging it. I'll just stick it there for now. And then the last thing we need in here, especially when it comes time to do the alignment, is we need the antenna in here. So I'll just set this over there. The Beamascope antenna. Now, and these radios with this chassis and this style of antenna, the antenna lead wires, every one of these I've done. This will be the 5th chassis like this I've done. The insulation on these wires just gives up the ghost. I'm guessing what they did was they used a type of wire here with very flexible insulation. At least it was initially. It's no longer flexible. More flexible than the rest of the wires. But unfortunately that led to a type of insulation that deteriorates and cracks like this, right exactly where you don't want it, because the antenna turns and the wires get flexed and bent, and eventually they do that. So you can see that, but these wires are essentially bare all the way through here. And this happens in, as I say, every one of these radios I've done. I've had to replace these wires. Now one of them I took entirely apart, or I took apart entirely, depending upon how you want to do your English there. One of these antennas, I took the whole cover off and all that. In the end, I thought, you know what, that really wasn't worth doing. I just wanted to replace the wires right from the top here all the way down inside. And in fact, I could have just trimmed them. And that's what I'll do on this one. I'll just trim them up here and attach new flexible wires back up into the radio, rather than open this up, because look, it's all stapled, it's paper. There's nothing particularly exciting inside here. I mean, there is a nice loop antenna, no question about it. It is definitely a designed antenna. And we don't need it right now, so I'm just going to set it aside. And really, well, all we need to do right now is just examine the chassis here and see if we can find anything seriously wrong with it before we really get going on it. So this is the speaker wire. 4 wires, 2 to the voice coil, 2 to the field coil. And most of the tuning is done here, and you can see how it's arranged. The chassis is constructed so that you can get at these different tuning controls just barely putting your hand in. And there's a couple more up here, some more stuff up here, one up here, but nevertheless these ones you can get at very easily without taking out the chassis. And I suppose, you know, on that account you can also get at the tops of the IF. The IF here. You know what? This looks like somebody's picked this radio up by the IF can. If you need to pick up a big old radio like this, okay, 2 hands always, and if you can do it, grab it by the power transformer. That's the bulk of the weight anyway. So you get 1 hand on here like this, and 1 hand maybe under the chassis here or something like that. Don't pick it up by the IF cans. Don't try to work it around. There's just no mechanical strength. They might feel solid. They'll feel solid when you start, but when you're done, they're going to be like that. And this looseness can cause a little bit of trouble in the radio. You don't want pieces of metal that are going in and out of ground to the chassis and stuff like that happening. So, but not a serious problem. Not a serious problem. So all the tubes are in place. See them all. I'm not sure, but I think I was told this radio works but hums, but I'm not sure I got that right. There's the magic eye. Now the magic eye in these radios also has it's a bit of a design problem here. Let's see if I can get it on camera. Right about there. The wires come out of the back of the magic eye, and they pass right by this tube, which I believe is the rectifier tube. Now this is a hot tube. So you have wires traveling right by this hot tube, often right in contact with it. Right in contact here with it. Here, maybe we'll look back this way. There, you can see it here. And these wires can deteriorate badly also. Now these ones look to be okay. I mean, they're stiff, but I think they're good. I don't think there's a problem there. Now let's tune the radio a little bit and see if everything moves or turns. There we go. Wow, the string is looking pretty old. And I'm turning it without the knob on here, and that reduces the leverage and makes it more difficult for me to turn it, which is fine, because in the start here, you don't want to get, if you have a large knob on it, you got a lot of leverage. You can crank this thing maybe a little harder or farther than you want to. Okay, so I already see a problem occurring with the string. Surprising problem too. Where's my close-up camera? Here it is. Let's take a little bit of a closer look here. I don't know if my camera's going to focus here. Let's see what happens. So as I was turning it, I could feel, as I was turning the knob here, I could feel the tension building in it. And if you look, you'll see the string here is binding under itself right there. And you can also tell, look at the string, you can see that this string is taking a beating. This whole wheel just looks like, it's kind of a green color to it, doesn't it? Just a little bit. So, but some kind of fairly ugly stuff is built up in here. So this string may very well break while I'm working on the radio. There's a good chance it will, because it appears so beat up. Now you might think this is a minor problem down here, and you know, to some degree it is a bit of a minor problem, but that's not supposed to be happening. It's not supposed to get tucked under like that. In the worst case, it really gets caught. And of course, when you're operating the radio, you can't see what's happening here, and you can start turning with the leverage of the fairly large knob on here. And this string will pull so hard that it'll either break at a weak point, or it's just going to wear itself out in here from extensive rubbing there. And you can see the alignment dial on the back here that we'll be relying on eventually. A little adjustment there, another adjustment there, alignment adjustment. So radio looks pretty good. Capacitor looks okay. Another thing that people tend to do by accident is they reach into these radios and they don't know what they're grabbing, and they get their fingers on these plates and they squeeze them together. That doesn't seem to have happened here at all. Not a real dust bunny either, so I think somebody's been in here cleaning this guy up a little bit. See, the tubes are not polished, which is good. It means probably all the tube markings are still on them, but it's no mystery what tubes are in this radio. This, I believe, is a filter capacitor. Probably that guy's a problem. Let's see, it's got a light down under here. Can you see where I'm pointing? Down here. Got a light. The light shines through here. So I don't know exactly what that is. That might be a band indicator. It's probably a band indicator there. Oh, wrong thing. Down here. Appears to be a green color there. So I think maybe the bands are different colors, and when you switch band, this is moving. Wouldn't bet on that. Wouldn't bet on. So I'm not exactly sure what that is, but we'll find out eventually. Got the two lights here that are lighting up the dial. The light bulbs look pretty new. Let's pop this one's popped off. We'll pop them back on. Okay, let's take a little peek underneath and see what goodies lie in store with this one. My experience with this particular chassis is, I'm going to knock that light off again, because I'm going to set it right on that light, otherwise. Okay. So here we are. Now, right away, these three wires hanging here. These three wires connect to this guy here, right here. And guess what? They were not connected. This was plugged in. This is more an audio part here, because if you see the wire comes up, connects around right into here, and this is a phono input. Or today we might want to consider plugging an iPod or something like that into here, which can be done on this radio. But without these wires connected, the radio cannot operate, and they were just laying up in here. That's another really good reason for not just switching on one of these radios. It's a really good reason for not doing that, because you don't know what's going on. So, so that's this radio was going nowhere with these wires lost up inside the cabinet like this. So, okay, and yeah, let's take a close-up look, because I'm seeing stuff already here. Take a close-up, we'll go through the whole chassis here. As soon as I switch on my close-up camera. Okay, let's start where the power cord comes in. This has been changed out by somebody. Let's look at the power cord. Type of plug on it. Okay, so it's a non-polarized plug. That seems okay. So these wires now head quite clearly. You can see them head to the switch. And then they head right into the transformer. You look at the transformer. There's no compound leaking out. There's no black tarry material coming down the wires or anything. That's pretty good. On some of these, an awful lot of the compound inside the transformer will have leaked out. Okay, that's very good. From here, we'll just start near the bottom of the chassis and work our way up. What we're looking for is anything that looks burned up, split open, in need of attention. Now, these molded black capacitors are bad actors. They tend to split open right on the seams. That one doesn't look too bad. This is pretty old stuff. These capacitors, wow, okay, they do not appear to be in very good shape at all. The wax coating that you would normally find on capacitors is pretty much gone on these. So I think we're going to be looking at changing them all. Now look at the end of that. I mean, do you think that's airtight, watertight, moisture tight? I don't think so. Just looking at it is making me feel tight. So lots of paper capacitors got to go in this radio. All those resistors down there are also of a style and a vintage that not terribly reliable at this point. But I mean, they look okay, so I'm not jumping at them. So every one of these capacitors has a you can really see the end of this one. You can see that there's a seal, you know, it's like a cardboard tube, if you like, with some junk in the end of it to seal the end, and you can see that it's basically open all the way around, and especially where the lead goes through. So, you know, what do you think? Think moisture-laden air works its way into here? Sure. Sure it does. See, that one looks terrible too. So, now, will the radio work with these capacitors in it? Well, it may very well work, even with these. Some of these are not in very critical locations in terms of the radio's operation, or the detriment to the operation of the radio is not something most people would even notice. There's a bigger one back there. I'm positive about it. Seems to be in a little bit better shape. It's possible that's a replacement, but I don't think so offhand. So there's some more of these. Look now that kind of capacitor, they're usually highly reliable. That particular shape of capacitor. Don't normally change those. Okay, look at that. There's some kind of a something there. I think that's an adjustment of some sort. Huh. Okay. What else can we find here? We're getting up into the radio front end circuitry. Let me just increase the light here so my camera frame rate stays high. Here's the switch. You know what? The switch is connected via a string up to a wheel that turns around and moves a colored disc. Here it is here. In that hole that we were looking at earlier. So that's what it is. So that's a band indicator by color, I guess. Another one of these. See, it looks like it's just cracked open a bit at the bottom there. It looks like the seam is giving out a little bit. There's a lot of these in this radio. Lots and lots and lots of them. Here's one here. Now look at this. Now here you go. Is that a crack or is that a shadow? I think that's a shadow actually. It's really the seams that kind of give out on these. It looks pretty good. Oh, there's a good example of what I'm talking about. So, look at that. You think that's any good? You know, it might still be, but I really doubt it. Well, that's the only one that looks really bad. There goes the frame rate on my camera again. Now, these coils are absolutely critical to the operation of the radio, of course, and a rather large amount of corrosion here and there on the chassis suggests this guy's been in a humid environment for an extended period. Just the look of all this, it all says moisture. Moisture, moisture, moisture. There's some more adjustments that come down through these holes. Moisture is not our friend. The universal solvent. We usually don't think of it that way, do we? As human beings, we think of water as some wonderful thing that we love to drink, and it is wonderful stuff, and we do love to drink it. And we hear about other planets where they have lakes of solvents. They, ooh, who'd want to live on a planet where solvents run around, you know, in lake-sized pools of solvent? Ooh, not very attractive. Well, that's what water is. Water is a solvent. We're just able to tolerate it and actually utilize it. Makes me think maybe there's other life forms that can tolerate other solvent-like liquids. In fact, I have some friends who actually drink a lot of solvent, and I don't think they're aliens, though. Well, okay, so there's nothing egregious here. I don't see any fire, any burned stuff, any... just look right up in this top corner here. It's usually the place you don't look where the problem is. I'm sure this radio's just been sitting happily in its cabinet, removed from the world except for the atmosphere. The atmosphere, get it. There's some capacitors often way down in here. See, there's a paper one back there. Really tough to get to. But generally, the chassis is open, fairly easy to access. So I mean, the parts are distributed nicely in it. You can work in here. It's really not that tough. There isn't a pile of wires in the way everywhere you go, like another radio I've just been working on. And open up the back, and it's just a jam of stuff. Really tough to work on. And potentially, this is a really nicely working radio. Good reception, good shortwave reception. It has the shortwave bands are spread a fair bit, which means the range they cover is actually small, so they stretch the range out over a large area, and then tuning is very nice and that. So a radio like this is well worth bringing back to life. I mean, you saw the cabinet; it's a beauty. Yeah, it needs a little refinishing maybe, but then again, you know, so do I. At my age, a little refinishing would help out. But okay, next step along the way here, what would that be? Well, we got our choice here. We could test all the tubes, see where they're at. We could apply high voltage to the high voltage circuit just to see if there's a short, or if the capacitors that need to support the high voltage are good. Look, there's a little bit of asbestos left on here. The asbestos has been removed from the radio itself. So I'll just wipe these off and It's a tiny amount anyway. I would not jump in and start replacing parts. You know, it's not my style, and I have not had the best of luck to just jump into a radio and start replacing parts. I'd much rather try to operate it as it is if I can figure out that it's safe to do so, find out where it's at, and then do selective part replacement. I'm pretty sure with this radio it really makes sense to replace all these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, about a dozen paper capacitors then. A really bad looking one here. So, and then obviously replacing this split one here, I mean, that's obviously got to be done. The rest of it is all a little less obvious. So my choice would be operate the radio as it is, after first reducing the level of risk, or analyzing the level of risk in doing that, which I imagine is very low. But another thing I do too, and any good radio guy's got to do this, I restrict the amount of power coming into the radio when I first turn it on. So if there is a short, I won't burn something out. And in particular, what I don't ever want to damage is this great big transformer here. They can take a fair bit of beating. It takes time for them to heat up, but I am thinking of a recent radio called the Low Opta with a damaged transformer. In fact, the radio is useless at the moment. So I don't want that to happen. So you don't just kind of plug these things in and see what they do. That's not quite the way to go. I can operate it without these attached. But I don't think, yeah, these are the antenna wires. I don't need these to be attached, I believe. But I think I got to put this in if I want the speaker to make any sound. And you don't want to operate these radios without the speaker plugged in. That's why I have the big speaker in here. It has to be, you have to have the speaker plugged in. Its coil, big field coil in the back, forms part of the power supply. So I guess you could argue it might be good to start it up without this plugged in, because you're actually interrupting the power supply, and you can sort of, you know, operate a small part of the radio first to see what's going on. That's interesting. Never quite thought of it that way. But of course you won't find out much, because virtually none of the radio will be operating by trying to run it without the speaker plugged in. Well, being the kind of guy I am, I think we'll stick a little high voltage in here, check the high voltage circuits to make sure there isn't something seriously wrong, and then we'll look at plugging them in. So you're not going to leave the video running here, because I'm going to get this going pretty quick. Okay, so we're going to make use of the high voltage power supply here. Where do we want to plug it? We want to plug it I don't have the schematic yet. You know, I've got a couple of versions of these laying around in my notes here and there. I can probably find it pretty quick, but I'm not going to go looking. We just want to spot the filter capacitor again. Okay. It's right here. Let's take a closer look at it, at the terminals on it. That's one easy place to feed in the high voltage. So where is it? Okay, so there it is. That's it, dead center of the screen there. Now, there's a good chance that all three of these terminals are positive capacitor terminals. 2 in the power supply and one smaller one to serve as the bypass capacitor on the output tube cathode resistor. So if we take a look, can we read on it? I don't have the schematic in my hand. There we are. 20, looks like 25, 25. Or am I reading that upside down here? I think we can see it better up through here. I can shove my camera down in here. Maybe I can't. Maybe I can't. There. Looks like 15, 450, 10, 450, and I'm guessing that's an 8 down at the bottom there. Is that right? We really need to know if this is a 2 or 3 part. It's pretty clear, the 15 and the 10. That's a typical capacitor size for a radio with a choke coil in the power supply, which in this case, the choke coil is also the field coil of the speaker. Can't quite get down there. 20. Sure looks like it. Let me just see if I can just see this with my own eyeballs here. The answer would be no, I really can't. It's just hidden behind all these parts. Very clearly 15450. Come on. Looks like 2025. 20, 25. What's that last word there? Huh. Come on. Ten 450. Here, I'm going to see it this way. 2025. Can negative. Perfect. That's perfect. That's exactly what we wanted to see. Okay, so now we can be reassured that in fact it's a 4-terminal capacitor or a 3-section capacitor. One of the terminals is the can, the actual can. So all 3 of these terminals here are capacitor terminals. Now you can kind of guess the ones with multiple connections are the high voltage ones, and the one with less, the one in the back here, is a low voltage one, but that's a guess. We really need to look and see if we can spot a little square or a little triangle down there, but chances are it's hidden by the chassis and it's not visible here, so the little clue is not there. Okay, so next, to be sure, follow some of these wires tied in a knot. That's not helping me much. Tied in a knot around that screw. Why would they do that? Because maybe they are coming out of the transformer and nobody wants to cut back a transformer wire. No. Well, it's possible when you buy this capacitor it came with its lead wires connected, or they connect them outside the rate. I don't know. I don't know why they have all this excess and then just tie it up. It's going in a knot through that hole. Hey, what's up there? What's up there? Just the tube and there's the capacitor. What's going on here? There's the capacitor and there's a hole. Is that another? What's that? That's not another capacitor, is it? Okay, so it's kind of right in there. There's nothing there. There's the hole. Oh, you know what that's probably going to be? Let's see. Oh, this is what it is. It's the speaker wires coming up. It's surprising to me that they would be right there. Well, that makes sense why they're tied in a knot, doesn't it? Because these wires actually go out of the chassis down to the speaker, and you can tug on them. Let me do some tugging. Now they're not moving the slightest bit under here, but of course when you were new and more flexible, when you tug on them, so that's why they're strain relieved onto this screw also. Now they've gone so solid, they're kind of permanently there. So that's a good sign. If it's going out on that speaker line, then that's the field connection, field cloth connection. That's gain. It's got to be these two terminals of the 3 on the capacitor, 2 on the right. Either one of the 2 on the right. Now, the other one, can I follow that all the way? Well, let's see, the output tube on this radio, pretty sure is this one here. Okay, so that's down in the corner. That's that guy right there, Mr. Output Tube. So if he's got a cathode resistor and a bypass capacitor, and that capacitor happens to, okay, enough talk. See that wire? That wire pretty much dead center of the screen now, disappearing behind the capacitor. That wire traveling along behind it. There it is there. Going up under the control here. I think that's it. So I'm just trying to absolutely convince myself of which part of this capacitor is which. And I think I've done that. I think I'm convinced. Doesn't mean I'm right. Just means I'm now emboldened to go forward. Okay, going forward. So we'll take the negative. We know the capacitor now is connected to the chassis via the can. Also more asbestos here. And we'll go right on the one leg. Now with the speaker not connected, there's a big gap in the power supply. And one capacitor is essentially connected into the radio, and the other capacitor is connected into the power supply, and the field coil is in the middle. But the field coil is not there. So I picked one capacitor essentially at random of the two. I've either picked the one that feeds into the radio or the one that's coming from the power supply. I don't know right now which one I picked. So, but we'll test both anyway. Because not only could the radio be leaking, the capacitor itself could be leaking. This is a metal can capacitor, so it's probably in good shape. Okay, so put this on standby. Give it a moment to warm up. And when we go to do the test, I'm going to rely on the two panel meters here, a current meter and a voltmeter. I'll crank it up to, this set probably runs with around 250, 300 volts on the tube, something like that. I'll crank this up to 150. That should be high enough to see any significant leakage that might be in the radio. Enough leakage that we don't want to operate it. That's really what I'm trying to figure out here. Okay, so I think we're ready to go. Nothing will happen with the radio. And more famous last words. This is down. Okay, see if I can do this without standing right in front of it. So I'll be watching this meter to make sure it doesn't go too high, and keep my eye on this one, trying to get this one up around this area here. There we go. I see this is rising, but this isn't moving at all. It is moving a little bit. I need a little bit of movement here to reassure me that my test is working. Let me just change the shop lighting here a bit. Make it just a little more visible for you. Especially if I don't put my hand in front of the light at this point. So just under 100. That's 150. 200 big volts, there's no current. So I'm probably on the non-radio. Ooh, what was that? I'm in here with both my ears. Even though you're listening in stereo, you don't have the real directionality that I have. That little popping sound seemed to me to come out of the speakers of my big monitor up there. That's something new. Don't know what that was. I'm going to ignore it for now. So we're going to switch now to the other capacitor. This is down. Put on standby just to be sure. The other capacitor terminal. I'm now guessing that this is the one that will basically energize the radio. I got a little discharge snap in there just now. That's kind of cool. Capacitors getting a little more than I bargained for on that. How come that didn't discharge? Didn't that discharge? It seemed to me that snap came from the terminal I'm just about to connect to, which shouldn't have any charge on it. So I could be a little bit confused about which terminal is which. We're just going to check and see if there's any voltage on top of these terminals now. 10 volts. 1 volt. Snap is not really a concern. It tells me the capacitor is able to hold charge and the circuit's hooked up to it. A little bit of trouble getting the clip on here. Okay, I think that'll do. So I think now I'm testing all the high voltage circuitry in the radio for leakage. But I could be wrong. Let's see. If this comes up and hangs, with a milliamp on it or something, then I'll be reassured I've got this right. Not that I have it right, but I understand it. This is going up quite a bit and going down slowly. Up around 200. It's up around 10 milliamps. So we're could be applying high voltage to some of the circuits here for the first time in decades. I really don't know if this radio's really been turned on. I don't know if it's high voltage has reached its circuits and that. Who knows? So 200 volts. The current has relaxed almost down to, who knows, half a milliamp. Now when I first run the radio, I'll run it in such a fashion that the high voltage is actually not fully there. Instead of maybe 300 volts, it'll be 200 volts, something like what I have on here. So we'll push this up a little higher yet. Around let's go up to 250. You can see the current charging into things. Charging forth. And it's slowly dropping back again to around maybe 2 milliamps, something like that. Of course, if the tubes were heated, then there'd be conduction through the tubes. Be much more current being drawn. Right now the tubes are off, there's no heat in them. There's no current flow through the tubes, there shouldn't be anyway. So I really am just kind of testing the static components, if I can put it that way. The things that are going to face this high voltage, but don't do anything more with it than hold it back. I'm also listening very carefully and talking too much. Okay, you know what? I think that's good enough. I think that's a pretty good test. Now, let's go see if we can find some of this high voltage on one of the tubes. That will tell me for sure that I've really got high voltage going through the radio. I'd be a little, certainly be surprised if that's not the case, but you know, it could be an open resistor or something. So we'll start with the output tube. I'm just going to go around the pins looking for anything up here around 100, 200 volts, something like that. 43 is a little weird. Oh, that was over 200 right here. So that's what's actually on the radio right now, 258, and my meter up there says, wow, pretty accurate. Ah, pretty much says 258. Wow, I'm stunned. The meter up here on this panel. Always surprised when things work. So that's the output tube. Now it tends to get kind of like an express high voltage feed. Let's go look at another tube. Every one of these should show up some high voltage at this point. Somewhere in here. Or am I not thinking of something? There's nothing on this tube. Yeah, that doesn't add up. Let's try. Oh, that might be the that's the rectifier tube, so maybe that's the one I should not be looking for. Actually, that's right. I've got the high voltage fed on the non-power supply of the field coil, which is missing. Let's try another tube. $146. Looks like 146 is going to be it. There's another tube way up in here. Let's see if I can get out of here. There, 260. The whole shebang's up there. So that shows me that high voltage is getting through the radio. Now, before I get myself something bad happens, so I'll let this discharge for a little bit, and I think from here we can plug this radio in. Wouldn't that be exciting? Plug it in with restricted power. Okay. I think when we do that, we'll lay this flat. Wires out here. Don't believe there's any voltage on those wires, just radio type signals. I don't think we want them shorting to themselves or to the case or to anything else. So as long as they're out here, out where? Out here. As long as they're out here, I think we'll be okay for the test. And I want to plug in the speaker. With any luck, yeah, with any luck, this kind of where nothing bad can happen to it. Yeah, put it right like that. Yeah, put it right down there, flat like that. So we now have the speaker plugged in. We do not have this plugged in. We have to plug in the audio portion of this, at least. Put this guy here. A lot of very fragile wires on there. On that switch panel. Okay, that's plugged in. Very good. Now, of course, this has to be switched to radio or something. I don't know what it's switched to right now. What about controls? Who's who here? That's the on-off. I think that's the tone control also. That's the band control, and this is the tuning. Very, very stiff tuning. Get that string so it's not an issue. There, so we're away from the pinch point on this string. So the objective now is to fire this guy up, hear something out of the speaker. Hum would be okay for now, and observe the tubes, see that they light up, and watch for smoke, flames, and the like. So now, just to be a little better prepared, we'll just keep this real handy here. Of course, I'm just kidding. I'm not about to shoot a fire extinguisher off in here. Okay. In fact, you wouldn't want to have your fire extinguisher there. Where's the best place to keep your fire extinguisher? I learned this from a fireman. Yeah, this fire extinguisher, by the way, is good for about 10 seconds. He said for most people, that's about how long it takes them to figure out how to aim it, and it's empty. 10 seconds or so. Maybe a wee bit longer out of this one. Not much here. The fireman said you should have your fire extinguisher mounted by your back door. And the reason for that is when you decide you're going to try to use it, you will run down to your back door, and when you get there, he said, forget it and just keep going out of your house. He was very adamant about these fire extinguishers lead to people getting hurt because they fight fires that this fire extinguisher cannot help you with. You know, that might help you put a cigarette out, you know, something like that. So that was his message. Keep your fire extinguisher at the back door so you can say goodbye to it as you run out of your house. Never put the fire extinguisher somewhere in your house where you have to run deeper into your house to get it and then come back and discover that in those 10 seconds or whatever it took you, the fire has gone from something that looks not too dangerous to something that is going across your ceiling at that point, and you're going to get killed. So, not that I'm an expert in any of that kind of stuff, but I just like delaying turning things on, give my brain a little more time to think. But I'm pretty sure there's no problem here. Pretty sure is good enough. Yeah, pretty sure. Okay, so we're in there. Now, restriction. I'm just reaching up here. Make sure that light's undone. Just on the one light. That's a heavy restriction. Maybe so much that the radio won't even operate properly, but that's okay because we just want to hear a hum, a hiss, and see some lights in these tubes. Maybe these lights are going to come on too. Switch is off. So first time we tested with the switch off to make sure the switch works. That is off, in fact. And also, I'm going to keep the camera up here so you can see my dim light bulb up there. I put that dim light in about the least handiest place it could be in the shop. Okay. There we go. Those lights should not, that light should not light. Fantastic. And you can't see it in that camera, but the little meter has come up here indicating there is definitely power. Power for the radio. Okay, no problem. Switch it off, turn the radio on. So here's another shop arrangement problem. That's not really the best way. I reach over to turn the power on. My arm is right above the thing I'm testing. It's really not the best arrangement. This switch should also be located with the fire extinguisher by the back door, really. Okay, but I think we're all set. This time the light should come on. It may come on fairly brightly at first. We should see it come on, dull down, and then come back. That's the hope. Whenever you're ready. There it goes. Came on. It's getting brighter. Ooh, I didn't like the look of that. That didn't look quite right to me. I don't know what you saw on the camera, but to me the light was not increasing at a steady rate. It seemed to jump, seemed to skip a little bit, like that. So I need to get re-nerved. Try it again. Didn't hear anything. Didn't see anything funny going on. If I didn't have that light there, I would never even hesitated. Let's give her another go. If a real short circuit develops in the radio, the light will come on full brightness, and I will grab the fire extinguisher and see you guys later. Lights are on. Come on. Kind of brightened up a little suddenly there. Oh, I see the problem. I see the problem. Okay. Who else could see that? Did you see what happened in this tube? Now, do I dare turn it on again? I think I will, because it's a little bit of a teaching moment here for all of us. I'm going to try this in the dark, which is another thing the firemen recommended against. If you think your house is going to catch fire, don't turn all the lights out first. And I want you to keep an eye on this. Okay? There we go. I'm watching it too. Interesting, my eyeball was watching that light up on the wall. Meanwhile, the action is right here and can be seen. There we go. Watch it now. See that? Oh, wasn't that exciting? So that tube's a dud. Now, had I plugged this guy right in the wall and turned it on, and I have the thing inside his cabinet, I can't see anything. If you notice, there was no sound from that at all. But that tube is shorting out. Exactly what's going on with that, I don't know. I couldn't tell you, but it's shorting out. It's going to draw a heavy current, perhaps. You're putting this transformer at risk. It's a no, 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 no. You don't want to do that. So that's the story. We got to pop this tube out and find another one. It's probably a 5Y3. Let's pop him out. Let's pop him out. Now these tubes, the rectifier tubes and the output tubes, are commonly the tubes that fail. 5Y4. The reason they fail is because they're hard working tubes. See how big it is? See this big guy? And if you look around here at the output tube, which I can't really, well, you can kind of see it here, it's a similar shape. It's big. And why are they big? Because they're really hot inside. Why are they hot? Because they're working hard. They're pushing lots of current through it. All the current working the radio is going through here. And likewise, the whole objective is to drive current into the speaker, and the output tube does that job. So these are the two tubes that are most likely to go. This guy, though, the rectifier tube, he stands a good chance of damaging this transformer. Wouldn't happen instantly, but if you turned it on and were fiddling around and then the phone rang, you went out of the room, when you come back it might be time to run for the fire extinguisher or leave by the back door again. I guess you could say they put asbestos under these radios for a reason. There must have been a fire rate to them. So I'm going to have to go locate one of those tubes. I'm pretty sure I got something that'll go in there. And maybe we'll give it another try right away. There you go. Oh, this is 1 hour now. You know what? That's how I'm going to start the next video. Yeah, I think that's a good idea. Hey, thanks for watching. Hope you're enjoying this. This is one of my favorite radio chassis, and I'm really looking forward to making this guy work well. So See you on the next video.